Hi, welcome to this video. I'm going to having a experience of 10 plus years in the mechanical engineering. So I'm reading the MFP since 5 years. So maybe approximately 5 to 6 times I have built this architecture. So today I'm going to discuss about this third unit. The third unit, which is telling about the plastic deformation. As you can see here, the first question is just is plastic deformation of the mechanical engineering, which is useful for the second year students. So here, I explain the first question is details of this plastic deformation in metals and alloys also. So metals also deform, alloys, metals mixing often there are, and also with reference to recovery, recrystallization, grain stock growth. So what is here? Taking the question, first question. So, what is happening? Plastic deformation in metals involves a permanent shape. So, once the plastic deformation you want to take change, it is going to take permanent shape of what it is there. Changes via dislocation of the motion. So the motion is happening, slipping is happening inside the atoms and molecules so that the plastic deformation is permanent, increasing the strength. So by doing this plastic deformation, what will happen? Increases the strength of that object, and also it increases the internal energy. It is going to also increase the internal energy. Strain hardening and cold hardening. So in order to increase the strength hardening, you have to do strain hardening. So annealing. What is annealing? What is annealing? Annealing is these materials triggers three restoration stages. What are the three restoration stages? Means here you can see first it is a recovery, and next is a recrystallization, and third is grain growth. So what is happening in the recovery stage means a dislocation. Dislocations are rearranged. So what is the spaces between the atoms and molecules? You can see here. So here more spaces, so it is less spaces in this recovery strength. So by doing this, what is happening? My durability is decreasing here, and the strength is increased at critical level. Hardness also increased. The next stage is recrystallization. What is the meaning of recrystallization? New grain nucleation. So you can see new nucleus as formed here. So new nucleus will be formed in the recrystallization state, that is the second stage. And the grain growth, it is also called as coarsening. So grain growth is here small grains together form big grains. This is called as coarsening or dense coarsening. This is a fine coarsening, which reduces the hardness while restoring the ductility. So what happens, here in the recovery state, the strength and hardness here as shown in the graph, they are very high. Here ductility very low. Here again ductility increases and more increases. Here from here stage recrystallization it is coming down. In the grain stage the hardness is coming down. Hardness and strength both are following same structure, while ductility is opposite in the first question, that is plastic deformation. So you have to remember these properties. Three properties. Hardness strength increases while ductility decreases, and vice versa. So explain the hard working and cold working process. Compare them. Second question is compare them. So what is hard working and cold work? So you can see directly hard working and cold working. Here below recrystallization temperature, that is the recrystallization temperature is 720 degrees. Below that, if a metal is undergoing some grain structure, it is called as cold working. Above 720 degrees centigrade, it is called as above recrystallization temperature, where it is undergoing a hard working process. You can see here, this is the cold is shown inside the metals. Here, hot is shown inside the metals. So, coming to the definition, it is a mechanical hot working process. What is hot working process is above the recrystallization temperature. What happens to the forces means lower forces are required because it is the atoms inside the metal are heated, so they require lower forces to shape themselves. And also the metal remains soft and ductile. So my metal will be always soft and examples where it is applied. It is applied to the hot rolling, forging, extrusion, and pipe welding. So, what are the hot working process means? Hot work rolling process. The rollers are used in order to do this one, and also forging. So, examples are hot rolling, forging, extrusion, and pipe welding. So, pipe, if you want to weld, you need hot working process. Extrusion to make the tubes, pipes, you have to hot process is done here also. Forging also hard process is done in the forging also. Rollers also we use big rollers two rollers, three rollers, four rollers. This is also done under hard working process or hard working environment. So cold working process explain or define what is cold working process means. Mechanical deformation carried out below the recrystallization temperature. Very important point to be noted. Trade hardening increases the strength, increases the yield strength and hardness. So strength, two types yield strength and normal strength, hardness. Both are distortion by the grain stroke. Examples, cold rollers are used, cold drawing is used, deep drawing is used, bending is used. So here this diagram I am explained already. Now I am taking the third question. Describe strain hardening and annealing process in the details. So what is a strain hardening means? What is the strain hardening? What is the strain hardening means? Strain hardening is also called as work hardening. So strain hardening is a process of strengthening a metal through plastic deformation. So through plastic deformation. What is plastic deformation? It is brought near the plastic deformation. So mechanism here we can see this is stress is taken on the y-axis, strain is taken on the x-axis. So this curve as you are seeing, it is going up and after that it is coming down. That means it is under the range of plastic deformation. After that it is going beyond that, it is a breaking stress. This breaking area, half of this breaking area is called as strain hardening here. So you can see the diagram here provided. So mechanism. What is the mechanism of a strain hardening? Why do you do strain hardening or work hardening? Is the process of increasing the strengthening. Strength to be increased mainly in the plastic. Plastic does not have strength, but we have to increase strength. So this process is followed here. As a metal is deformed. So when your metal is deformed, it can be rolled, it can be drawing, it can be bending easily. The density of the dislocation within the crystal structure increases. Also, crystal increases. This delocation multiply and becomes entangled or pinned, making further movement difficult. So, further, what happened? Dislocations or multiple dislocations will be there. They will be pinned out and they will be straight in the order. So, next to fourth question I am taking. Explain about bulk forming process with suitable examples. What is happening now? Bulk forming process means here you are having bulk forming process. So four diagrams are shown here A, B, C, D. Okay. Now bulk forming process are manufacturing methods. Now, one of the manufacturing process that use large scale plastic deformations to change the shape of the metal. Okay, to change the shape of the metal workpieces with a low surface area to volume ratio. So low area and low volume. So area increases, volume decreases. Volume increases, area increases. For example, billets, rods, slabs. So these are the best examples. This process typically involves significantly compressive forces. Compressive forces are used. It is usually performed as a hard working to produce heavy duty parts like gears, engine components, and raw stocks. Means raw stocks are inventory controls. Mainly we are using gears and also engine components here. This one. So here ma, you can see two rollers are used here. Two rollers rotating opposite ma. This workpiece is coming here. The diameter, the area here, see, bigger area here, smaller area. It is producing tubes ma. Tubes like structures here. The force from two sides we are giving, from top side and back side. Here, die is used, two dies ma. In between, I am fitting some plastic material that is a workpiece, and I am from top down. It is fixed. It is a movable. I am forcing this, so it will take this oval shape. And oval shape object, distilleries or anything, it can be formed here. So here also you can see ma, this force is given from backside ma. Here it is workpiece. Okay, it is ram ma. The ramming of this is done on this fluid ma, or the material, liquid material. It is coming out with some velocity v. So this is the workpiece. Now here what happened? This diameter is changed to this diameter. You can say pipes are reduced to wires. Okay, wire pipes are reduced to tubes. Now here also some tubes, these tubes are forced here to go through this diamond. Again, they are coming into wires. It is also having some velocity v f here as shown in the figure. Fifth question, describe forging process, types of forging, defects and remedies in the. So, forging process, open die forging, closed die forging. The metal is placed between flat or simple shaped dies that do not fully contain the material, typically used for large and simple parts. So, closed die, open die will be there. This is metal is placed between the flat or simple shaped dies. Here, the metal is placed between the two dies. You can say this is a open die. So, this is a closed die because four sides it is closed. Closed die, the metal is placed in a die cavity and force is applied to make the metal conform to a die shape. It produces more complex pieces. So this is a die is closed all the ways. This die is not closed all the ways. So you can take this is a open die, this is a closed die. And also you can take sixth question. What is happening? Explain about rolling process, fundamental types of rolling mills and products. So in the rolling, you can see two types of rollers are used, opposite direction. Okay. Here, three types of rollers are used here. So one is backup roller here, and also four types of rollers, two backup rollers and two working rollers. Small rollers are working, and they are backed up by big ones. Here you can see. So definition, if I am going principle, pulled into the material is pulled here into the gap. So what is happening? The rolls, between two rolls, rotate in opposite direction. They are rotating in the opposite direction. This is definitely reducing its thickness. So this thickness is reduced to this thickness. Further, this thickness is reduced to more thickness, less thickness, while increasing the length. But area is decreasing, length is increasing. I said area to volume before, often without changing with significantly. Hot rolling performs above the recreational temperature where we use the for reduction heavy ignites, blobs, slabs into the structural sheets. So long products here, bars are used, rods are used, wires are manufactured. What is the seventh question? Explain extrusion process. So here extrusion process is there. Different types of extrusion process. Direct extrusion process, indirect extrusion process. So this is a ram is used here. Ram is used. Some force is given to this one. It is some wires are coming out of this dias. So here you can see, this is a indirect. You are putting a force or a ram force on this liquid, on this metal. This metal is going to the end. Again, it is coming out of from the center point. So this is a indirect. We are not going. We are applying to this material going at the end again coming from this middle one. This is the indirect type of extrusion process. So this is the different types of this one. Here also you can see this is a tabular one. Tabular one. Here you are giving force. It is a container. It is a ram which is giving force here. Material pushing through this tube. It is coming out of this mandrel. Here you can see hydrostatic extrusion. Here also. Here from ram you are putting force not on the material ma. Water is there, liquid is there, or oil is there, some fluid, oil or liquid. So it is giving forcing on this oil or liquid. This oil is going and putting force on this raw material. This raw material is coming out of this dye. So this is the extruded product. So this is the hydrodynamic, indirect, direct, tubular one. Now, take the definition one. Extrusion is a metal forming process that reduces the metal cross section by forcing a heated or a cold billet through a shaped die using a hydraulic ram. Definitely, one ram force should be given from the backside. So, producing long, uniform, solid hollow profiles. So, long wires, long tubes, pipes can be manufactured in this extrusion process. It is primarily classified by metal flow direction, indirect or indirect, temperature, hot or cold, and pressure methods, hydrostatic or impact. So if I am not wrong, I am going to take the eighth question mark. Describe the impact extrusion and hydrostatic extrusion with the advantages and applications. So impact, this is the impact ma. You are going to give a punch on this die ma. In the die, material is kept. This will take the material of this die ma. So here, see, punch and die both are okay together, and in between some workpiece material is there. So this is a impact material. Hydrostatic material is there ma. As I said, the ramp is putting pressure on this fluid. It is a oil or pressure. Then that oil and pressure is going to put on this workpiece. This workpiece metal. This workpiece is coming out of tubes here. So this is a hydrostatic ma. A billet is surrounded by a liquid medium, especially oil or water, inside a high pressure chamber. The hydraulic fluid forces through the billet, through the die, eliminates friction and billet and container. Okay. Last one, but not least, explain wire drawing and tube drawing. So both ma, from tube you are getting wire, from wire, that is the final one. Here you can see ma, this is the cross section area A naught and AF. This is a die ma here, and this raw material section A naught is decreased to AF. The force is given. They are going to pull from here ma. They are going to pull it. They are going to draw. Drawing means pulling. So wire drawing reduces the diameter of a wire or a rod by pulling it through a conical die. So this conical die is used, and they are going to pull it outside ma. This is usually a continuous cold working process performed at room temperature. Just room temperature they are performed. The starting rod is pointed, passed through a die, gripped by tongues on the draw bench. So you can draw bench and they can pull it ma. Last question, compare the forging, rolling and extrusion process. As usually I am giving all the explanations. You can write diagrams side by side and you give definitions ma. That is more than enough for counting. For example, what is forging, rolling, extrusion are primary bulk metal deform process only. They are the deformation ma, that shape the metals through plastic deformation. Forging means compresses metal using dies ma. Okay, in order to increase the high strength. Rolling means reduces thickness by passing metals through the rotating mills. Extrusion means forces material through a die to create the complex shapes. So this is the comparison ma. With this, I am ending this unit 3. I hope you have and I have understand. I have covered all the important questions which are necessary in this one. Hope good luck for you. Okay, please like and subscribe this channel. If share with your friends and also any suggestions, please give me. I will be uploading into next videos. Thank you. Thank you very much.